All right, hey you guys. Okay, so I'm going to teach you how to do a certain type of Hess's law problem. But remember with Hess's law, what you're doing is you're trying to find, let's say you had reactant A and it converts to B, and you want to find what the enthalpy of that reaction is. Now, Hess's law says that you can use all sorts of different pathways to find the net result of going from A to B, and that's what you're trying to find here, which is similar to, let's say, a bank account, whereas at the beginning of the month, let's say I had $50, and at the end of the month I had $60, which means that my net change, let's say, is $10. Well, you guys know that if you have a bank, excuse me, you have a bank account, what really mattered was that at the end of the month, you saved $10. But there was probably a lot more activity going on in terms of withdrawals and deposits during that month than just a $10 deposit. And so what Hess's law says is that it doesn't really matter the pathway you took to get to here. It didn't really matter the pathway that you took to get to here. What mattered is that you got there. And so, for instance, you may have some alternate routes. So let's say you have A going to C and C going to B. That means your pathway may look more like this, and it might be 2 steps, okay? And what you would do is you would add the enthalpy of this reaction and this reaction, and because these cancel out, and the reason why they cancel out is because if you were to take reaction 1 and reaction 2 and add them together, really you have A plus C and then C plus B. And because these are the same on both sides and they didn't change, then really what you're looking at is this. And so you were able to take these 2 reactions, add them together, cancel out things that were the same on each side, and the ultimate goal of adding up reaction 1 and 2 is to get A going to B, and that's what we got. So what you can do is you can not only take the reactants and products in this and add them together, but you can also take their enthalpies. Okay, so I'm going to move back up to where we started. Sorry, a little technical difficulties here, you guys. Trying to look for where I was. All right, well, I'm going to take 2 examples right here. And these are from a different worksheet than the one that I've assigned. This one is posted on Moodle also, and it's the first 2 problems. It's actually 6 problems on a worksheet. 3 through 6 are very hard, so I would only use those for additional practice after you've done a different worksheet. But what this worksheet is it's saying that if I have these 2 reactions and their enthalpies, I can use them to try and find this one. And in the case of number 1, it's actually so easy that all you have to do is add them together. So you can basically take reaction A and B, add them together, and see if you get this reaction that you're trying to find. And if you look, things that are on both sides of the equation, like when I add it together, this is on the reactant side and the product side, so they can cancel. And then basically what you're left with is these 3. And so when you add together, you end up having 2NO2, you have the N2 that gets brought down, and the 2O2, which means that then all you have to do, because you're adding the 2 reactions together, is add their enthalpies together right here. So your answer to this is as simple as negative 68 kilojoules. And so that is the enthalpy for this reaction. Okay, so let's move on to this one, because this one actually has a little bit more involved in it. Okay, so for this one, what you're trying to do is you're trying to take reaction A, B, and C and add them up so that you get this. And the way it is right now, if you add them up, you don't get this reaction. So we're going to need to do a little bit of manipulation. So there's some strategy involved in this. And what you need to do is you need to focus on, okay, I have to get CH4 on the correct side, and I have to get solid carbon on the product side, and I have to get this as well. And there's a whole bunch of stuff in here, for instance, like waters and oxygens don't exist anywhere else. And what I can do is I can manipulate the problem. So for example, I want to get solid carbon. And so if I want solid carbon, I need 1 mole of solid carbon, and I need it on the product side. And so if you look, the only place in these 3 equations that solid carbon exists is in A, but it's on the wrong side. So I'm actually going to take reaction A and I'm going to rewrite it, and I'm going to flip it so that it's backwards. And states of matter are important, but for this I'm not going to write all of them. Okay, so I have that, and then whatever I do to my reaction, I have to do to my enthalpy value. And so here you can see it was a negative. So I'm going to take it and I'm going to turn it into a positive. Okay. And so there, for A, I'm done. Now I'm going to look at the next thing, which is my, well, I guess we'll go with this. I need 2 moles of hydrogen gas, and look and see if it exists anywhere. And the only place it exists, so what you want to do is you want to start with the unique things. So like in A, I started with carbon. It only exists in one spot, and that was in reaction A. So my only shot at getting 1 mole of solid carbon onto the product side is by flipping reaction A. I'm going to do the same thing with the hydrogen. I need 2 moles of hydrogen. Well, the only place that hydrogen exists in these 3 problems is right here, and I have only 1 mole of it. I need 2. So I'm going to take reaction B, and I'm going to multiply the whole thing by 2, which means I've got 2 H2O now, turning into 2 hydrogen gas. And instead of having a half mole of oxygen, I have 1 mole of oxygen. So I'm going to take this and I'm going to multiply it by 2, which means that now I have 800 kilojoules. Okay? Now the last thing is equation C. I've manipulated A and B so that I've got my star things right here. These 2 are what I want here, so they're all set. Now I need to focus on my methane. And the methane, the only place it exists is right here. Now what, you might be worried like, okay, sorry, I had a little glitch. So you might be asking now when I look at C, I've got to be focusing on the methane. And so you might be asking, okay, well, what about all of these oxygens and waters? And we're just going to hope that after we manipulate the unique things like the methane and the solid carbon and the hydrogen, that the others will cancel out. So we're just going to deal with the things that are unique that we have to deal with. So for instance, we need methane on the reactant side. The only place it exists is here, and it's in the amount that we want. And so in this case, we just have to write it as is. And we're going to hope that it works. Okay, so we have the methane plus 2 oxygen, and that gives you carbon dioxide and 2 water. Okay, and we did not adjust this one in any way. Negative. Okay, sorry, a little messy. All right, so we're going to hope that when we add this up, we've got all of our necessary ones that are in the right format. We're going to hope when we add this up that everything cancels. So we've got carbon dioxide. It exists. I have 1 mole of it here. I have 1 mole of it here. And you can cancel things that are in the same quantities and on opposite sides of the equation. And I have 2 moles of water here and 2 moles of water here. And so those cancel. Now I have, I've got a water or an oxygen here and an oxygen here and here. But these 2 moles will cancel with the 1 and 2 moles there. So this one and this one, that's 2 moles, cancel with that one. And what you should have now, excuse me, is when you add them all up, you should have CH4, this one right here, and these are the only things left. Solid carbon and 2 of those. Okay, now that looks a whole lot like this, which is what you wanted at the end of this problem. So the important part is that you now add up all of these. So when I add up positive 555 and positive 800 and negative 1247, I end up getting a delta H for this of 104 kilojoules. And that is the answer. What you have to do now at the end of all of this is keep in mind that you have problems that look like these. Okay, so I'm going to, you have problems that look like these. Now on the worksheet that I gave you, they're in a little different format. This is what you're trying to find, and on the worksheet that I asked, this is actually written like up here, and these are below. Bottom line is you're going to take several equations and you're going to manipulate them so that when you add them together, things are on the correct side in the correct amount, and they cancel to give you this final equation here. So you have a worksheet to work through on that, and these two are on a different worksheet, the two that I've given you right here. There's 3 or 4 problems below it that you can do for extra practice, but they are much harder than the worksheet I assigned. So the worksheet I assigned looks different from this, but has the same type of problem as these 2 examples. The 4 below these on a different worksheet you could do for extra practice, but I've gone through these 2 with you. I recommend that now you open up the worksheet that I provided. Do those, and if you still want to work through more, then do number 3 through 6 on this sheet. Okay, so remember, these examples are on a different worksheet than the one I assigned, and the format's a little different on the one I assigned. The type of problem is exactly the same, but you'll find that this is written in the problem, and these are below. Okay, so that's it. And if you have questions, I can certainly try and answer them for you in a different setting or even via email if you need.